Good morning, everyone. From my point of view, nematodes are the future of biocontrol, and I might be very biased in that opinion since I've worked with these guys for 6 to 7 years. But what we found and what I now realize in my research is we can go on about EPNs being really good for a biological control program, but if you don't have enough of them, you're never going to be able to apply them in the field. And that was the crux of my research, trying to produce enough of these nematodes so that we could give them to our local farmers. So you're asking me why, Why are nematodes so important? Now, I'm sure those who are in the field doing the work, they are very familiar with why nematodes could be such a good biological control agent and why they fit so well into an IPM program. They are natural enemies of soil-dwelling insect pests. Already we know that that is a good foot to stand on. What I love about nematodes, and the way I always describe them, is that they're like little hunters, and I often refer to them as wolves. So if my insect is on one side in the soil, and I apply my nematodes here, they will be able to go and locate that pest insect inside the soil. And there's not many biological control agents that can actually do that. So that gives them a significant advantage over many other existing and developing biocontrol agents. But as I said, we need enough of these so that we can give them to our farmers en masse. And that's what I researched. So we began our research with this little guy on the right-hand side there, Steinonema jeffrehense. He's a very large nematode. So we use that as the model organism because it's a very easy nematode to mass produce. But it is not as good as a nematode as our star species, which is Steinonema jeffrehense. Now, what makes all of these EPN species such good biocontrol agents is that they have a symbiotic relationship with bacteria, and that bacteria is actually their secret weapon and is also what they use to feed upon, and again is the key part of mass producing them artificially. So when we first started this research, we were only able to produce a very small amount of nematodes in our flasks. And after 6 years of tedious work in the lab and scratching our heads and trying to figure out how do we increase yields that simultaneously will decrease your cost, this was my second chapter of my PhD, we were finally able to do just that. So we did a series of experiments where we looked at different medium ingredients or different dietary ingredients to see what the response would be from the nematodes. And if we just start on the left-hand side, we started by looking at different protein sources. And what we found quite interestingly was that egg yolk seems to pick up the yield substantially. And once you've got increased yields for the same amount of media, naturally the cost of the production decreases as well. So we hit a sweet spot, seemingly. And we decided, okay, well, let's not stop there. Let's try some other things. So we went on to the next most important ingredient in the artificial diet, which was the lipid source, or as some of you will know as lipids are olive oil, canola oil, any kind of oil like that. The two main ones we wanted to try were olive and canola because those had a very distinct property that we wanted to look into. What we found was, though olive oil is far more expensive than canola oil, they achieve the same results. So naturally, we hopped over to canola oil, further reducing the price. And we said, well, let's not stop there either. Let's keep going. And we looked at the next most important ingredient, which was nitrogen. And the nitrogen sources we looked at were marmite, yeast extract, which was the current yeast source that we used, or a low-grade yeast. And what our results showed is that we couldn't actually replace that high-end lab-grade yeast extract. So unfortunately, on our final experiment, you could say we got a bit of a dud, and all the good work that we had done in the final experiment, we didn't see that same result. However, we still saw this as a positive, because what ended up happening is from when we first started and our first diet that we used to what we can do now, we've reduced the price of producing nematodes substantially from 460 Rand for a billion to 104 Rand. Now what that means is we recommend between 1 billion and 2.5 billion nematodes per hectare of land. Now that can change depending on the type of insect and how you apply them, whether you apply them to hot spots, whether you apply to just beneath the tree, or whether you cover the entire hectare of land. Either way, we've been able to reduce that price significantly and produce more nematodes at the same time. So this was an absolute highlight of my master's and my PhD. Out of all the 6 to 7 years of researching, this was the golden standard that we present to almost all conferences and all symposiums, that we've been able to do this, which has made it far more viable to do this at a commercial scale. So once we had that in the floss, the next natural step is to scale up to bioreactors. So we started with a custom-made bioreactor you can see on the top right-hand corner there. And Prof. Milan and I, with absolutely no engineering background, we started looking at the engineering side of this, which is process or chemical engineering. And these are the results that we were able to get, picking up our results in the bioreactor trials to the same level that we get in the floss, which is another huge step forward. What that allowed us to do is provide nematodes for all the other projects around us and allow us to formulate nematodes to use in even larger trials. And that's where we are currently today. I'd like to thank everyone for listening to my presentation. If there are any questions, please feel welcome. Thank you.